Hello. In this video, we are going to begin looking at parallel and perpendicular lines. So, what does it mean for a pair of lines to be parallel? This means that the slopes are the exact same, signs and numbers. The lines will never intersect. So graphically, this means that they will indeed be parallel, just like your ceiling and your floor, or your two opposite walls. Perpendicular lines, the slopes are opposite reciprocals. So, an example, if one slope is 3/4, the other slope would have to be -4/3. The lines will intersect at a 90-degree angle. Here we have a graph. We see these two lines and they're intersecting at a 90-degree angle. If the slopes do not meet either of these criteria, meaning their slopes are not opposite reciprocals or their slopes are not the exact same, then the lines are neither. I'm going to say that again. They're neither if the slopes are not the exact same or if they are not opposite reciprocals. All right, so we're going to determine if the pair of lines are parallel, perpendicular, or neither. We have two equations. Our first equation is 8x minus 6y equals 42. To determine the slope of an equation, we must get it in slope-intercept form, which was our previous video. We need to subtract 8x from both sides. That's going to leave us with -6y equals -8x plus 42. We then need to divide everything in the equation by -6. So -8 divided by -6 is 4/3, and 42 divided by -6 is -7. So our slope is 4/3. In our other equation, we have -3y equals 9 minus 4x. Y is already isolated with the exception of the -3, with the exception of its coefficient. We can rearrange where our x is in the front so it's more familiar and more resembles our textbook definition of slope-intercept form. So we have -3y equals -4x plus 9. We need to isolate our y completely, and we're going to do that by dividing everything in the equation by -3. So -4 divided by -3 is 4/3, and 9 divided by -3 is -3. So our slope is 4/3. What do we realize about our slopes? They are the exact same. So our lines are parallel. In example 2, we're going to once again determine if the lines are parallel, perpendicular, or neither. We have x equals 2 and y equals 2. There's no way to get these equations in slope-intercept form, so we're going to look at them graphically. We also discussed vertical lines in our previous video. X equals 2 is going to intercept the x-axis at 2. Y equals 2 is going to intercept the y-axis at y equals 2. Now, we're going to move this function over, and we're going to see that these intersect at a 90-degree angle. Therefore, these two lines are perpendicular. That concludes this video for parallel, perpendicular, or neither. In our next video, we are going to begin writing linear equations.